Let's move on to ranking with the rank method. So I'm going to use the score column, and it's easier to see when we use only 10 values. So I'm going to do score.head10 and just call this score 10. So I'm going to use this series, just 10 values. So score10.rank. A lot of people get confused with rank and sort. They are related, but ranking does not sort. So notice that the index is the same when you rank. We're providing a numerical ranking. This is the same thing as if we're ranking some sprinters in a race. So we're going to be giving ranks from 1 to 10. So the movie with it's actually the lowest score gets ranked number 1. So if we look over here, Spider-Man 3 in this 10, not out of all the movies, but just in this series, has a score of 6.2. So it is ranked number 1. John Carter has a score of 6.6. It is given a rank of number 2. Next is Spectre at 6.8. It's given a rank of 3. And then, so this is interesting, we have 2 movies tied at 7.1. And so there are many different ways of handling ties. So by default, the average is used for ties. This is just the method. So here is 4.5, 4.5. That is its ranking. The way average works is that you just take all of the possible, what rank it would have been. So this would have been ranked 4 and 5 if they weren't tied. And then you average them together. So 4 and 5, the average of that is 4.5. Interestingly, the next ranking, the next score, so after 7.1, there's 2 movies with 7.5. So they are given a ranking of 6.5. So you might be wondering, why did it jump from 4.5 to 6.5? Well, if they were no ties, this would be ranked like 4, and then 5, and then 6 and 7. So it takes the average of 6 and 7 and gets 6.5. So you can change the way that ties are ranked. Let's do a couple of them. By default, it is average. We can say min rank. So what's going to happen here is that instead of using a tie, like an average 4.5, we're going to use the minimum. So they would have been ranked 4 and 5. So the minimum of that is 4. These would have been ranked 6 and 7. The min of that is 6. If you see max, it'll be the opposite. So the maximum, that's 5 for those 2. And this would be 7. A dense rank is like min, but it doesn't skip any numbers. So here we have 1, 2, 3 are the same. When we get to our tie, they're both given 4. That's the same as min. But then the very next movie is given 5. It doesn't skip any numbers. It's dense, right? So you're not going to have any skip numbers. The highest ranked over here is 8. That is the highest. The actual score is over here, 8.5. It's the highest score. It's given a rank of 8, even though there are 10 movies because of the ties. And then just like score, or just like sort values, you can rank in the opposite direction, which makes more sense with movies. When you think of movie ratings, the highest number should be given ranked 1. So we can do average like this. This is the default, so you don't have to put it. So here now, sorry, I need to do ascending. So let's get rid of average, actually. What I meant to do is ascending equals false. The default method is average ranking. So now The Dark Knight Rises, the highest ranked movie is given place number 1, rank number 1, Avatar 2, then Tangled 3, and then these 2 are tied at 4, so it uses the average ranking over here. All right, so that's ranking. Notice the index stays the same. The values are now turned into ranks, right? So usually a number between 1 and n, where n is the total number of values in that series. Okay, so pretty cool rank method. You're not going to use this one as much as the sort values. Usually you're sorting, but every once in a while you want to get a numeric rank.